Hi everybody, I'm Meenachi working as an assistant professor. Today we are going to discuss the topic on feature selection for classification. So before going into our topic, we will have a quick look into the definition of data mining and steps involved in pre-processing the data, and after that we will go into our topic. So first of all, what is data mining? The data mining is a process of extracting the patterns from the large amount of data. So these data has to be pre-processed before extracting the patterns out of it. So why we have to pre-process those data? So the data which are available, they are incomplete, noisy and inconsistent. The pre-processing step, what it will do is, it will make the data complete, noiseless and then consistent. So if the data are complete, noiseless and consistent only, it can generate the patterns meaningfully. So for pre-processing, there are major tasks involved. They are data cleaning, integration, transformation, reduction and discretization. Data cleaning is, in a particular data set, you may get the missing values. Some noises may be there onto the data, or the data may be inconsistent. So to solve out these problems, the data has to be cleaned initially, and after that integration. So integration is the task where the related data are grouped together so that it can be processed easily. So if those data are scattered in the database, it will be very difficult to combine those data and process. So instead of, to solve those things only, you are integrating the data and you are processing it. Next is your data transformation. So data transformation, that is moving to the next level, either normalization or aggregations can be performed. The next one is your data selection or your reduction. That is, you have your large volume of data present in the data set. So from those, the minimum data alone it is taken. So the minimum data which is taken, it is going to produce you with the result which is more or less similar to the results produced by the whole set of data. So here the data reduction, in the data reduction, the selection of data has to be done in such a way. Next is your data discretization, where this is involved with the numerical data. So next is your data reduction strategy. So as I have already mentioned, the warehouse may store terabytes of data. So the complex data analysis mining may take a very long time to run on the complete data set. So to avoid those problems in data reduction, the minimum volume of data it is taken, so which is going to bring you with the same result or similar result as your whole data set is considered. So different data reduction strategies are involved, that is data cube aggregation, dimensionality reduction, numerosity reduction, discretization and concept hierarchy generation. From this, we are going to discuss in detail on the dimensionality reduction. So what is a dimensionality reduction? So the dimension here specifies your attribute or your feature. That is your attribute subset selection. Minimum number of features, that is feature or the attributes from the data set alone it is taken. From that the pattern is extracted. Instead of going into the numerous attributes and generating patterns out of it, going into the minimum minimum attributes and generating the pattern. So it is going to produce you with the same result as the previous one. That is considering, that is reducing the number of patterns in the patterns. It is easier to understand too. Take an example in decision tree induction. Here it involved this particular example having the 6 attributes present and 2 groups of classes, that is class 1 and class 2. So in order to categorize these, in order to specify the features, characteristics of these 2 classes, it is sufficient to have the 3 attributes A1, 4 and 6. A2, A3 and A5, even if it is present, these attributes are not considered also, these classes are categorized. So from this, the reduced attribute set is A1, A4 and A6. So this is what your data reduction it is. In the real data set, you may have number of attributes present, 100, 200 attributes may be present. From that, the feature selection it is done, it will be meaningful. So here to explain you the concept of attribute reduction, I have considered the 6 attributes alone, and from that which are the attribute which is relevant I have told you. But in the real world data set, you may have number of attributes present. From those attributes, the attribute reduction it is performed, and it is performing the pattern extraction in the sense it will be very the time consuming task also it will be reduced, and it is also going to produce you the more result which is more or less similar to that of your original whole data set. So the feature selection. The feature selection is that is selecting the relevant attributes alone, removing the redundant or irrelevant attributes. So here relevant attributes in the sense, so in order to take for example, in order to diagnose a particular disease or something else, in that case the relevant attributes, whichever features which is used for diagnosing a particular disease alone it is taken. Whichever it is not necessary, for example, the patient address may not be the relevant attributes for diagnosing a disease of that particular patient. So in that case, these attributes can be considered as irrelevant, or the redundant attributes in the sense, for example, the age and date of birth are the 2 different attributes present. Both are one is derived from the other. So if any one attribute it is present, it is sufficient for classify your particular data. So in that case, those redundant data and irrelevant attributes can be removed. So the reason for feature selection. So while doing your feature selection, it is going to produce you with the simpler model, faster model induction and structural knowledge. The evaluation methods involved, that is feature selection, it is involved with filter methods and the wrapper method. Filter method is what is, each and every attributes are considered individually and they are ranked. After that, those ranked attributes which is having the higher rank, it is selected and then it is used for pattern extraction. It may be either individually the attributes are considered or subset of attributes may be considered. The wrapper method is what is, the subset of attributes is considered and subset of attributes is taken and subset of attributes are evaluated and from that best subset it will be selected. So that is what is your wrapper method is. So the filters, it may be either the ranked list of attributes or select the subset of attributes. So in your filter method, the evaluation of your filter, so the each and every attributes are considered individually. So the higher correlation will be done with the class attributes, lower correlation will be with the other attribute. In wrapper method, I have already mentioned that a subset of attributes are taken and those attributes are repeatedly evaluated to get the best subset out of, best attributes to perform the pattern extraction. So that's all regarding your feature selection. Thank you.